Hello there and welcome to Upper 6 Further Maths. Here we're looking at series by method of differences, so we can answer questions from exercise 2a. So series links into the lower 6th Further Maths topic of series. It's summating numbers, but this time we're going to be doing it by method of differences. The way you did it in the lower 6th was you helpfully remembered a couple of formulas. The sum of 1 is equal to n. The sum of the first n integers, the sum from 1 to n, is equal to n over 2n plus 1. The sum of the first squared numbers, that's 1, 4, 9, all the way up to n squared, is with this formula here, n over 6n plus 1, 2n plus 1. And the sum of the first cubed terms is this formula here. Now this is how you did it in the lower 6th. What we're going to be doing here is using a different method, and along the way we might be proving a few of these formulas. And hopefully you also remember the rule that if you have something like a 2n squared inside your summation, you can factorise out that 2 to the front, because effectively you'll just be factorising that number from the summation, so you can move the number to the front. Okay, so here's how series by method of differences works. If you're trying to summate a sequence where you can represent that sequence by the subtraction of the function f, where you substitute in r and then r plus 1 into the second part, then if you were to add that series together, if you think about it, how would the series go? It would start with u1 equals f of 1 minus f of 2. Doesn't matter what this function is, doesn't have to be related to u, the sequence u, it's just some function, but it's the same function every time. Then when you substitute 1 in and you take away the substitution of 2 in, the next term in the sequence will be substituting 2 in, take away substituting 3 in. The third term in the sequence will substitute 3 in and then 4 in. The fourth sequence will substitute 4 in and then 5 in. If you just carry that on, and then substitute n in, so n plus 1 and n, then if you add together all of these terms here, then what effectively you're going to get is a lot of cancelling out. So you'll have the 2 substituted in, 1 will be a negative, 1 will be a positive. Substituting 3's in, they will cancel. 1 is a negative function here, 1's a positive function here. Same with 4's. 5's would cancel out in the row below. So 5 would cancel out in the term below. N will also cancel out with the term above. So that term would also cancel with the one that would appear here if we were to write out the full list. And what we've got left is just f of 1 and minus f of n plus 1. So that's the answer to this question. It'll be f of 1 substituted in minus f of n plus 1 substituted in. So it's method of differences because there's a lot of differences here, a lot of subtractions. Could be called the method of subtraction, method of differences, where we're just going to be cancelling out terms that reappear in the sequence, so that we just get the first term and the last term generally. Sometimes the function will be the other way round, so it would be f of r plus 1 minus f of r, but we'll see that when we come to it. Okay, so in the first question we're going to look at, we're first going to verify that 1 over r plus 1 is equal to 1 over r minus r 1 over r plus 1. This method of differences topic does link in quite well with partial fractions. And then hence find the following using the method of differences to find the summation for that sequence there. So first thing, we're going to try and prove that this right-hand side equals left-hand side. So starting with the right-hand side in this expression, let's now use our rules of taking away fractions to make the denominators equal. Making the denominators equal on both fractions there, and then doing the subtraction. So expand the brackets first, then do the subtraction. R plus 1 minus r, that would just leave us with 1 over r plus 1, and that's equal to the left-hand side of what we're trying to prove here. So great, we've done part A, and now we've got to move on to part B. So what part B is going to do is it's going to prove the formula for this series summation by noting that this thing we're trying to summate here is equivalent to this thing here. So we might as well prove the summation for this thing here instead. So these two summations here are equivalent because the thing that we are summating is equivalent. This thing here and this thing here, they are algebraically equivalent, so the two summations will be equivalent as well. So with this thing on the right hand side now, let's think about what will happen when we substitute 1 in. So when we substitute 1 in, we're going to get 1 over 1, that's the first bit, minus 1 over 2. Substituting 2 in, we're going to get 1 over 2 minus 1 over 3. When we substitute 3 in, we're going to get 1 over 3 minus 1 over 4. When we substitute 4 in, we're going to get 1 over 4 minus 1 over 5, and that will just keep on going up until we get to n, and that's going to be 1 over n minus 1 over n plus 1. So now let's summate this. So we'll now add up all of these expressions here. So the 1/2 will cancel because we've got a negative half here and a half here. The thirds will cancel because that would be minus a third and a third, positive third here. The quarters will cancel because we'll have a negative quarter here, and we would have a positive quarter if we were to go down into the next line. And you can see what's going to happen here. It will cancel out from top right to bottom left. So this bottom left one here would cancel out with the top right hand one there. So the summation of 1 over r plus 1 will be equal to this summation here, and the answer to this summation here, we've used method of differences on it, will give us 1 minus 1 over n plus 1 squared. And if we simplify that expression, we get n over n plus 1. So there we are, that's the answer to that question there. The summation from 1 to n of 1 over r plus 1 is equal to n over n plus 1. Okay, moving on to the next question then. In this question we're going to show that 4r cubed is equal to this big long thing here. And what you can see is that we could use method of differences on this expression on the right hand side here. If we look at the left hand terms, that's only 1 apart from each other, r and r minus 1. And the right hand expressions is going to be r plus 1 and r. It looks like the left hand side is always going to be 1 bigger, the substitution in, than the right hand side. And then we'll hence prove by using method of differences we have this expression here. Now we recognise this from using this in the lower 6 further maths, but we're going to prove it here in upper 6 further maths. So first of all we need to show that this thing equals this thing here, so we'll start with the right hand side of this expression, and we will first of all expand brackets. So square the brackets, move the r squared term inside the brackets to avoid making any negative mistakes. Then we'll group all the terms together. R to the 4 will cancel out on both of them, given that there's a negative in the middle. Minus 2r cubed, that will make it into a positive, but the r squareds will cancel out, leaving just 4r cubed. So moving on to part B, what we're now going to do is we're now going to summate for 4r cubed, and the summation for 4r cubed is algebraically equivalent to summating for this. It's algebraically equivalent because the things that we are summating are equivalent. So what we'll do is we'll use method of differences on this right hand term here. So let's write out for r equals 1, the summation will be this. Don't bother calculating what this is, it's actually easier for you just to leave it in terms of what you get when you substitute it into the formula. Substitute 2 in and you get this, substitute 3 in and you get this, ... substitute n in and you get this. Yeah, so it's helpful that we haven't actually worked out what these are numerically, because we can now see that this would cancel out with this. We can see that this will cancel out with this. We'd see that 3 squared and 4 squared would cancel out with the thing under 2 squared and 3 squared. So you have to imagine what will happen next. And then we'll see that this thing here will cancel out with this thing from diagonally left above it. So what we're left with is just the summation of what we've got left, which is this thing here and this thing here. So the summation of this expression here is equal to n squared n plus 1 squared. But what we're trying to prove is that this expression here is equal to this expression here. So what we'll do then is we'll write that this is equal to the original expression. We'd used a summation for 4r cubed first, but now we want to show that just r cubed equals this. So we'll divide through by 4. Divide through by 4 and we get a quarter n squared n plus 1 squared. So what we did for part B was we basically proved that the summation for this expression here is equal to something quite simple. That is equal to the summation for 4r cubed, and then divide through by 4 and you get this thing here. And moving on to the final question that we'll go through in this video then. So we're going to start with find the following summation using method of differences for 1 over 4r squared minus 1. Now what we've got to bear in mind first is that method of differences links in very neatly with partial fractions. So we're probably going to be doing this by splitting this into partial fractions. So it's going to be a over 2r plus 1 and b over 2r minus 1. We've done the difference of two squares on it, and then we've got two fractions. So what we'll now do is, using the technique of partial fractions, create common denominators on both of the two terms, and then group them up together. And then what we're going to look for is for the bottoms to be equal to each other, but then for the tops to equal each other as well. So we're looking for 1 to equal this top thing here. So 1 must equal a brackets 2r minus 1 plus b brackets 2r plus 1. So expand the brackets. Or we could set r equal to a half here. And if we substitute r equal to a half, we'll get 1 plus 1, that's 2. 2 times b equals 1, so b must equal a half. And substituting in minus half, we get minus 2a plus 1. So minus 2a equals 1, and then a equals minus a half. So now we know that b is a half and a is minus a half. We can write down that 1 over 4r squared minus 1 is equal to minus 1 half over 2r plus 1 over 2, 2r minus 1. Let's factorise out that half to the front, and then swap the fractions round the other way, just to make it look a bit nicer. So we've got a half brackets 1 over 2r minus 1 minus 1 over 2r plus 1. Okay, so what we've now just shown is that this thing here is equal to this thing here. So what we'll now do to find the summation of this thing here is we'll summate this thing here. So this thing here is equal to this thing here. What we'll probably do first is we'll move the half to the front and then just think about what this thing here is, and then bring the half back in at the end. So for r equals 1, just ignoring this half for now, we'll bring it back in later on. It's going to be 1 over 1 minus 1 over 3. Substituting 2 in, we're going to get 1 over 3 minus 1 over 5. Substituting 3 in, we're going to get 1 over 5 minus 1 over 7. If we carry on doing that, substituting n in, and we're going to get 1 over 2n minus 1 minus 1 over 2n plus 1. So let's now cancel using summation by method of differences. And then this thing in the bottom left here will cancel out with the thing on the top right. And we're left with this thing here, add this thing here when we add all of these terms together. Let's just simplify that. Don't forget to bring the half back in and carry on simplifying just to make it super nice and easy. Then we can cancel out the 2 here with the half at the front, and we'll get n over 2n plus 1. So there we are, that's the summation for this expression here. Ooh, and we've just got one more to go then. Express the following using partial fractions, and then we'll do a method of differences on it. So first things first, do the method of differences. So do the partial fractions, so we'll split it into two separate fractions. and then equate them, so equate the denominators so that we can add the fractions together. Then the numerators must match up with each other. These numerators here must match up with these numerators here. So substitute strategic values in to make this process a bit easier. Put -1 in as r first, and we get 2a equals 2 and a equals 1. Put r equals -3 in, and then that will cancel out this bracket here, so that will be minus 2b equals 2, so therefore b equals -1. So therefore this expression here can be rewritten as this expression here. Lovely. So now that we know that this expression here can be rewritten as this expression here, to summate this, we're going to summate this thing here instead, something that's algebraically equivalent to it. So we're now on to part B. We're now going to use the method of differences. So we'll plug in r equals 1. That gives us a half and then minus a quarter. When we plug in 2, we get a third minus a fifth. 3, we get a quarter and minus a sixth. 4, we get 1 over 5 minus 1 over 7, and that will just carry on. We'll do n minus 1, we'll substitute that in, and we'll do n, and we'll substitute that in. So, now what we're going to get is if when we add all of these terms together, we can see here this is slightly different. Terms cancel out with those two positions either earlier or later, and this is why we've done r equals n minus 1 has been included as well. So we can see here that the minus quarter will cancel out with the quarter that's 2 terms away from it. The minus fifth will cancel out with the fifth 2 terms away from it. The minus sixth and the minus seventh will cancel out with 2 more terms when we plug in 5 and 6. And also the n, 1 over n, will cancel out with minus 1 over n 2 terms before that. And then 1 over n plus 1 will cancel out with minus 1 over n 2 terms before that as well. So actually what we're going to get here is, when we add things up, a half, a third, minus 1 over n plus 2, and minus 1 over n plus 3. 4 terms here. So now let's just algebraically tidy this up. Create common denominators on all of the terms. I'm sure you know how to do this, you're all further mathematicians. And then we can then summate the numerators. And then simplify, expand the brackets and simplify. And we get 5n squared plus 13n. Now we need to factorize to get it just how they want it. So factorize the n to the front, and it's going to be 5n plus 13 over 6 bracket n plus 2 bracket n plus 3. So there we are, that's the answer to this final question. So sometimes when you do method of differences, it doesn't just cancel out with the line below, you may have to jump a line to 2 terms later on to cancel that term out. And sometimes you're left with 4 terms, just like we were here. Alright then, your turn to have a go at this question here then. Pause the video and give this one a go. Okay, so we need to start off by doing partial fractions. So it's going to be something over r plus something over r plus 2. And this is going to equal 1 over r plus 2. So let's now times top and bottom here by r plus 2. And we're going to get a multiplied by r plus 2. Because the r's will cancel out. We've got a divide by r and a times by r. Then it's going to be b multiplied by r equals 1. And you can do the method of differences so the partial fractions method where you equate the denominators and you'll get exactly the same thing. So now we'll plug in r equals minus 2. So that's going to give us b multiplied by minus 2 equals 1. So therefore b will equal minus a half. And we can also plug in r equals 0, and that will give us 2a equals 1, so therefore a will equal a half. So the answer to this question is that 1 over r plus 2 is going to equal 1/2 for a, so that would be a half over r, plus, sorry, no, it's minus for the b term, minus a half over r plus 2. So we can factorise out the half to the front, and it's going to be 1 over r minus 1 over r plus 2. So there we are. Remember that for the next part. Let's move on to the next part then. So remember it as 1 over 2 times 1 over r minus 1 over r plus 2. So now we're going to find the sum of the series for this thing here. Well, if this thing that we're summating is equal to this thing here, then the series of this is going to be equal to the series of this. So the summation of 1 over 2 r minus, so 1 over r minus 1 over r plus 2. Let's substitute in r equals 1 first. That's going to give us a half. Actually, we'll just cancel out the half and leave it to the end. So it's going to be 1 over 1 minus 1 over 3. When we plug in r equals 2, we're going to get 1 over 2 minus 1 over 4. When we plug in r equals 3, we're going to get 1 over 3 minus 1 over 5. Let's just do a dot 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 now. When we get r equals n minus 1, we're going to get 1 over n minus 1 minus 1 over n plus 1. And then when we plug in n, that's going to give us 1 over n minus 1 over n plus 2. So let's have a look at then what will cancel out when we add all of this stuff together. So the minus third will cancel out with the third that will appear 2 terms later on down here. Same will happen with the quarter. If we were just to do one more term, we'd cancel out the minus quarter here. And if we were to do one more term on from there, we'd cancel out the minus 1/5 as well. Also, if we were to go 2 terms before on the bottom, we'd cancel out this r equal, so the 1 over n minus 1, and the same for the 1 over n, that would cancel out 2 terms above as well. So when we add up, we're left with this, and this. So that's going to be 1 minus, so plus a half, minus 1 over n plus 1, minus 1 over n plus 2. So now it's just a case of rearranging that algebra to make something a bit more neater. So let's create common denominators. It's going to be 2 bracket n plus 1, n plus 2 as the thing we're going to multiply everything by. So that's going to be 2n plus 1, n plus 2. In the next term, it's going to be everything but except the 2, because we're dividing by 2 there. So that's going to be n plus 1, n plus 2 over 2n plus 1, n plus 2. Then it's going to be minus everything apart from the n plus 1. So that's 2 bracket n plus 2 with the same denominator. And then minus 2 bracket n plus 1 over 2n plus 1, n plus 2. Nearly run out of space there. These questions are quite long, so let's now expand the brackets on everything. So it's going to be, in fact, let's just do a big line and then 2n plus 1, n plus 2. This is going to be the final denominator now that we've made them all equal. So on this term here, it's going to be 2n squared. Then it would be 3n, but times by 2, that would be 6n. Then it would be 2, but then it would times by 2, which is 4. Then it would be n squared plus 3n plus 2. Then it would be minus, and we're taking away everything on the top here, so it would be minus 2n and minus 4. And we're taking away everything on the top here as well, so it would be minus 2n and minus 2. So the next thing would be to group this together. It would be 3n squared, 6n plus 3n minus 4n, so that would be 9, but then minus 4 is 5. And then it would be add 4, but then take away 4. Then it would be add 2, but take away 2, so there would be nothing left there. So it would then be 2n plus 1, n plus 2. And then we might want to factorise out the n at the start, so it'd be n bracket 3n plus 5 over 2 bracket n plus 1 n plus 2. And there we are, that's the answer to this question. Actually, probably we spent most of our time rearranging an algebraic fraction rather than doing method of differences here. But this was a question here where you had to do method of differences but missing out a layer to get to something that cancels out. So method of differences is just basically a series method of adding stuff together where most of that stuff cancels out. And there we are, that's all we're going to do for series method of differences. So have a go at plenty of the questions from page 36, exercise 2a. There's a big link between algebraic, so this method of differences, and partial fractions, but there are other different types of questions that don't involve partial fractions, and definitely have a look at those ones as well. The problem solving ones, the exam style questions, make sure you do a lot of practice on this, because this is going to be the only video that goes through series by method of differences. Lovely, thanks very much for watching, and hopefully you found this video helpful.